Your FastMCP server has Descope Authentication configured, but how do you actually verify the connection works end-to-end? We'll use the standard FastMCP client pattern to test the OAuth integration. Just 10 lines that handle connection, authentication, and verification. The client automatically manages tokens based on your server's configured provider, whether that's Descope's remote OAuth, client credentials, or other supported methods. And the simple ping call confirms everything is properly secured. From FastMCP import client. Import Asyncio. Async def main. Async with client. http://localhost 8000/mcp auth equals OAuth as client. Assert await client ping. If name equals main. Asyncio run main. This demonstrates the OAuth client pattern for secure service communication, where authentication details are abstracted behind a standardized interface. The code establishes a connection to a FastMCP server using provider-agnostic OAuth credentials, with the client library managing token acquisition and session maintenance automatically. The distinctive aspect is how the same client code works across different OAuth providers, with the specific authentication flow determined by server configuration rather than client implementation. The pattern works through FastMCP's Async context manager, which encapsulates the entire authentication lifecycle within the Async with block. When initialized with auth equals OAuth, the client negotiates credentials using whatever OAuth provider the server specifies, handling token storage and refresh transparently. This separation of concerns lets you write provider-agnostic client code, while the server dictates the actual authentication mechanism, whether it's client credentials, browser flows, or other OAuth grant types. This approach matters because it standardizes secure communication while accommodating different authentication requirements. The same client code can work with Auth0's browser flows, GitHub's OAuth, or client credentials. The behavior adapts based on server configuration. The trade-off is that first-time authentication for interactive providers may require browser interaction, but subsequent requests use cached tokens, balancing security with usability in development and production environments. Let's break it down line by line. From FastMCP import client. Imports the client class from FastMCP, the primary interface for MCP server interactions. This handles connection management, request serialization, and authentication, with behavior that adapts to the server's configured OAuth provider. The actual authentication flow, browser-based or credential-based, depends on server-side provider settings, not the client code. Import Asyncio. Imports Python's built-in Asyncio library, enabling asynchronous I/O operations. This provides the event loop and coroutine support required for the async main, function, and async with context manager used in the FastMCP client connection. Without it, asynchronous network operations like the ping check wouldn't be possible. Async def main defines the async entry point for the script. This is the standard pattern for async execution, enabling await calls within the function. The main name follows Python convention for the primary execution coroutine. Async with client. http://localhost 8000/mcp auth equals OAuth as client. Establishes an authenticated connection to FastMCP using the Async context manager pattern. The auth equals OAuth parameter enables OAuth authentication, with the specific flow, browser-based or credentials-based, determined by the server's configured provider. The context manager ensures proper connection cleanup and token management, while the server must be pre-configured with matching OAuth provider settings. Assert await client ping. This verifies server connectivity before proceeding with operations. The ping method acts as a health check, while assert enforces immediate failure if the connection is invalid, preventing silent errors in subsequent API calls. This follows the standard client initialization pattern for FastMCP services. If name == main. Python's standard entry point guard ensures the async event loop only executes when the script runs directly, not when imported as a module. The generic auth = OAuth parameter enables OAuth authentication, with the specific flow determined by server-side provider configuration. Some providers like Auth0 GitHub trigger browser-based flows, while others may use client credentials or service accounts. Asyncio run main boots the async event loop and executes the main coroutine. The Asyncio run call is mandatory for top-level async scripts, as Python won't auto-start the event loop. This follows the standard pattern for running async code from synchronous entry points like main. Async client pattern. This minimal FastMCP client demonstrates the standard async connection pattern, using Python's context manager for automatic resource lifecycle and token management. The auth = OAuth parameter enables provider-agnostic authentication that adapts to whatever OAuth provider the server is configured with, from client credentials to interactive flows. Server-side provider configuration determines the actual authentication mechanism. The same client code works with Auth0's browser flows, GitHub's OAuth, or Azure's tenant-based auth without modification.
The connection that knows no provider speaks all their languages.